So let's take a look at another example here. I want to determine all intervals of concavity and local extrema along with any inflection points that may exist for f of x equals 5 plus 3x squared minus x cubed. Well, obviously the very first thing I need to do is take a look at the first derivative. So f prime of x will be 6x minus 3x squared, which, because I'm going to be looking or setting this equal to 0, I think I'm going to factor this and write it as 3x times 2 minus x. And now I can see from here I have a critical value at x equals 0 and x equals 2. So these are candidates for local extrema. Now let's take a look at the second derivative. F double prime of x equals 6 minus 6x. That implies that x equals 1 is a candidate for an inflection point. So what I want to do in terms of determining the concavity, let's take the second derivative, f double prime, and evaluate it at each of these. Well, f double prime of 0 is in fact 0. Oops, I'm sorry. I was looking at the first derivative. F double prime of 0 is 6, and all I really care about is that is greater than 0. And then, let me see here, I have f double prime of 2, which is negative 6. And all I really care about here is that it's less than 0. So what this is telling me is that since the second derivative is positive at this particular critical value, that this critical value represents a local min. Seeing the second derivative is negative at this other critical value, that means that I have a local max at x equals 2. So let's see, I've determined the local extrema. I need to confirm the intervals of concavity and the inflection point. So I'm going to go back to the second derivative. And the second derivative had a critical value of 1. So what I want to do is I want to take a look at values to the left and to the right of 1. So how about 0 and 2? Well, I already did the second derivative at 0. It is positive. And I already did the second derivative at 2, and that was negative. So because the second derivative changes signs here at 1, I now know that I have an inflection point at x equals 1. And concavity-wise, I know that I'm concave up on negative infinity to 1. And then I switch over to concave down on 1 to infinity. So quickly here, I jumped to maple, and let's take a look at this. I said here that I had a local min at 0 and a max at 2. Concave up from negative infinity to 1, which this is clearly concave up. And then the 1 looks reasonable in terms of an inflection point. That's not too hard to convince me that the inflection point really is somewhere in there. And then from 1 on, I'm concave down. So I've identified and verified everything in here that was asked for.